In this class, we will understand one of the very important concept which is applicable to any programming language. So the concept is methods to represent negative numbers in binary. So far in our previous classes, wherever we have done programming concepts or programming examples, there we have deliberately used the integers or the numbers to be positive numbers. We have never seen an example which is based upon the negative numbers, because to avoid that confusion, so how the negative numbers are represented on the memory, that we haven't discussed it so far. We have seen how the positive numbers will get stored on the memory in detail. Now in this class and from this class, we will understand how the negative numbers are represented. So there are three ways by which the negative numbers can be represented. The three methods are, the first one is sign magnitude method, and the next one is ones complement method, and the third one is twos complement method. In this class, we will understand the first method, which is sign magnitude method. So let's get started with our explanation. So we are going to understand sign magnitude method, and very important point that you have to keep in mind for any of these methods is always the leftmost bit. So whatever may be the number of bits that are used to represent a number. So for example, if you take these sequence of bits, so these are 4-bit representations of numbers, and in any kind of bit sizes, so it may be a 4-bit number representation, or it may be 8 bits, or it may be 16 bits, or it may be 32 or 64 bits. Always remember that the leftmost significant bit is used for sign. It may be a sign magnitude method, or it may be ones complement method, or it may be twos complement method. Always the leftmost bit is used for sign. 0 is used for plus sign. So let's try to understand this by using an example. For example, if you have plus 5 and minus 5. So this symbol, it is a plus symbol, or it may be a minus symbol. These symbols are represented by these leftmost significant bit. So if the leftmost significant bit is 0, then it is a positive number. If the leftmost significant bit is 1, then it is a negative number. So this is common for any kind of method used for signed representation. It may be ones complement method, or it may be twos complement method, or it may be sign magnitude method. Always remember that the leftmost significant bit is used for sign. So now we will understand the concept of sign magnitude method. The name itself is stating that sign magnitude. So what it means is, as we have discussed that the leftmost bits are always used for sign. So I am going to separate the leftmost bits and the remaining. So here we are using 4-bit representation. The remaining 3 bits are used for magnitude. Try to understand this. The remaining 3 bits are used for magnitude. Now let's see how these numbers will get converted. How these numbers will get converted with this representation. Means the leftmost is used for sign. So here the first number is 0000, 4 zeros. So being the leftmost bit as a 0, so we are going to take it as plus, and magnitude of 000, it is 0. So the binary representation in 3-bit representation for 000 is 0. And similarly, if you take the next number, it is plus 001, means the magnitude is 1. Sign magnitude method. And if you take this, it is plus 2, and this is plus 3. So this number is plus 3. This is plus 2. Now the next number is plus 4. So if you remember those binary number representation, 100 is used for 4. So it is plus 4, and next one is plus 5. This one is for plus 5, and this one is for plus 6, and this one is for plus 7. So this is how we have seen. So this is how the sign magnitude methods will work. Now coming from here, if you take this, now the symbol is 1. The leftmost significant bit is 1, which means it is negative. And the magnitude 0, 0, 0, the same sequence of 6. So all these bits will repeat again. So if you take the 3-bit representation, the remaining 3-bit representation starting from 1, and for 0 they will repeat. See here. So pause this and see the sequences. Okay, so now it is minus and it is 0, and it is minus and it is 1. So it is minus 2, minus 3, minus 4, minus 5, minus 6 and minus 7. So these are all the numbers that are possible with 4-bit representation. Try to understand this. So what are the numbers that are possible? It is plus 0 to minus 7. So plus 0 to plus 7 means, if you take it closely, it is plus 7 to minus 7. So these are all the numbers that are represented by using this sign magnitude method. Okay, but this is not practically implementable. Why? Because this number system supports zeros in 2 different ways. This creates a confusion in the entire computer industry, which is plus 0 and minus 0. So there is no such thing called plus 0 and minus 0. Whenever the calculations come across with this sign magnitude method, the computer will get confused whether to take a plus 0 or minus 0, which is not existing. Okay, so that is the reason why these methods, these sign magnitude method and ones complement method is not practically used. The practically real-time implemented sign method to represent negative numbers is 2's complement method, which we are going to understand in our next coming video. So that's it for this video. In the next video, we will understand the concepts of 1's complement method and 2's complement method. See you in the next class.